All right, and we are live. Welcome on in, everyone. Robert, the AP Math Guy, and tonight we're going to be talking about implicit differentiation. So let me go ahead and adjust my camera here. There we go. And we'll go ahead and focus in our camera. There we go. All right, so I got a new camera, or not a new camera, a new notebook. This one goes side to side, so that way we don't have to deal with we don't have to deal with we can have our paper at a on a level angle. So yeah, welcome on in, everyone. I'll go ahead and start waving at people for that are here. We're going to start in a couple minutes, but first, let's go ahead and do a quick mad tap to 1K if you're here. Meanwhile, I will go ahead and wave at everyone who is joining us. And if I can't wave at you by clicking button, I'll go ahead and wave to you now. Hi, everyone. Yeah, hopefully everyone's Monday is going well. I was watching the Chargers Raiders game before this so fantasy wise I'm done. I'm still waiting to see Justin. My opponent has Justin Herbert and Cameron Dicker going on right now, and I have like a 20 something point lead as of halftime. So hopefully that stays, and hopefully I can win that game. Hello, how's your night? It's going well now. How about yours? My night is going well. Hopefully yours is going as well. Hopefully yours is going well as well. I also picked up some new math books, so that's always awesome. So yeah, so like I said, tonight, pretty good doing some math homework at the moment. That's really cool. Um, what topic are you doing right? What topic are you working on? Thought this was bad till I got to sequences and series. Oh yeah, I will do this over sequences and series every day of the week. Every day of the week will I do this instead of sequences and series. Those sequences and series aren't all bad. At least I don't think they're all bad. At the moment, linearization. That's cool. That's really cool. I have linearization planned here soon. Not sure if it's direction vector for tangent line. Awesome. Yeah, it'll be a little while before I get to Calc 3, but I do hope to get there probably by well, I don't know when. I'll be honest with you. I don't know when I'll get to Calc 3, but I'll get there in time. Awesome. No, definitely. And like I said, it's really I want to give you guys as much information as you need for when we do get there. That way we're ready to go. Because math is a foundational subject. It's not one that I can just bounce between subjects. But yeah, so welcome on in. So, in a couple minutes we'll go ahead and begin. Let's see if we can't get to 500 likes before we get started. Thank you for the rose, Tyler. Thank you for the rose. It really, that's awesome. I love these lives. If you did vids explaining concepts, you definitely go viral. That's the goal. I do my best. Yeah, I have to do more. I have to do more shorts more often. Also, your handwriting is so good. I'm inspired. Oh boy, my handwriting is okay. It it's gotten better, but as you can see, sometimes I speed write a little bit. Thank you, Tyler. I'm really happy to hear that. You're the best. You're all the best. I wonder, is this straight? I think so. Looks good to me. But yeah, so oh wow, we're at a K already. Wow. I think tonight's gonna be a good night. We're gonna do some implicit differentiation. We're gonna have some fun. So why is it important for us to know implicit differentiation? Because soon we're going to be doing these things called related rates. In fact, we're going to spend we're not going to get through related rates all in one night. I think we're going to spend a couple nights on it. Hey CJ, how's it going? Cheers to you as well. Which reminds me, I need to drink some water. There we go. So yeah, let's go ahead and get started. So as I said, we're going to be covering implicit differentiation, which is going to be something that we need to cover for when we get to related rates. And we're going to do, once we get to related rates, we're going to spend a couple days there because there are so many different types of related rates problems that I want to make sure that we are all that you see as many as possible. So, with that, what is implicit differentiation? So sometimes we're going to have things that have more than one variable. So in the past, we've seen functions with one variable, but well, functions only have one variable, but sometimes we're going to see equations that have more than one variable. So let's suppose I have something like x squared plus y squared equals 25. And we're going to be asked to take the derivative of that. So the rule is that so Calc 1 is known as single variable calculus. In fact, Calc 1 and Calc 2 are single variable calculus. Calc 3 is when we're going to take something called multivariable calculus. But for now, let's go ahead and figure out what we're doing here. So when I do calculus, we usually differentiate or integrate with respect to one variable and one variable only. And usually that variable is x, but sometimes it's not. So for tonight, we're going to assume that the variable we're differentiating with respect to is x squared. So here's what I'm going to do. First, I'm going to take the derivative of both sides. So I have the derivative of x squared. What is the derivative of x squared? What is the derivative of x squared? Don Gamer says no clue. Okay, thank you for the honesty, Don Gamer. Ryan says 2x. Dad says 2x. PJ says 2x. Joe Quinn says 2x. Justin says, I think this is a circle. Go to the poll says Dos Equis. Alexander says 2x. Hey, Brandsy, how's it going? Yeah, so the answer is 2x. And why is it 2x? Well, it's 2x because of the power rule. And remember what the power rule says. Let me get my note cards. Power rule says that if I have x raised to the n power, its derivative is going to be take the exponent, move it out front, and subtract 1 from the exponent. So I have 2x. 2 moves out front. X to 2 minus 1 is 1. So remember that a variable without an exponent is the same as x as that variable raised to the first power. May I see the rules list? Absolutely. So here's 1. And we're technically not done with the rules list quite yet because I think we still have a couple more functions that we need to find derivatives of before we can complete the list. But I think we're almost there, if we're not already. So this is three note cards long. I'm going to try and zoom out so you can see as much of it as possible. There you go. Can you see it all? Thank you, Dine, for the 21 goats. And thank you, Dark Manta, for sharing the live. Thank you, Snowman, for the follow. Left one you can't? Okay. Can you see it now? You don't understand any of this? Fair enough. That's okay. You came to the right one, you meant. Okay. Like that? Thanks for this, man. I got a quiz on this tomorrow. I appreciate it. No problem. No problem at all. What are you looking at? What am I looking at? So we're looking right now at our list of derivative rules. So the derivative tells a story of the slope. So it tells us what the slope of a function, how to find the slope of a function at a tangent line at a single point. Thanks, I'm barely going to learn this. We are still on continuity. That's okay. That is okay. Don't be sorry, Alex. No need to be sorry at all. Keep up the good work. Thank you, Nicholas. Thank you, Dine, for that. 3 Blue 1 Brown has great series of calculus on YouTube. I agree. I watch him from time to time as well. I want to see chat's reaction when you start doing dx dy. We're going to get there in just a moment. So, last week I just learned about the power rule. Okay. Is this type of stuff engineering people do? Yep. Engineers use calculus. That is correct. There are a lot of fields that use calculus. But these are just the list of rules for derivatives that we've gone over thus far. So, I'm going to go. I assume that have you had a chance to take a photo or that I think it was you, Alex, that was asking for this list to be brought up. Yeah. Were you able to take a photo? Awesome. I'm in a high school calc class and it's nothing like this. It's probably just getting started. Some of this is new to me. I took business calculus. Okay. That's okay. So, here we go. So, that was a pretty simple derivative, right? The derivative of x squared is just 2x. Now, I want to take the derivative of y squared. So again, just like power rule, I'm going to take my 2, move it out front, and subtract 1 from the exponent. So I have 2y to 2 minus 1, which is 1. But remember, we can only differentiate with respect to one variable at a time. Since x is the variable that we are going to be differentiating with respect to, I need to essentially do the chain rule. So, thank you, Jocelyn, for the follow. So, what I need to do is because my x is the variable that we're differentiating with respect to, I need to put this in there. So I have 2y times dy dx. Thank you for the follow. So whenever we have y squared or y to any power, because we're differentiating with x, I need to tell myself that I need to put a dy over dx, because this says derivative of y with respect to x. So then, what is the derivative of 25? Ryan says 1, Alexander says 0, Mock says 0, Louis says 5. Okay. Understanding says 0, 0. So let's go ahead and find out. Let's look at our rules. What does our rule say? If f of x is equal to a constant, then its derivative is going to be 0. That's right, actually. Any constant's derivative is 0. So I'm going to put the derivative of 25 is 0. Now, our goal with implicit differentiation, I can't stop here because the goal is to get dy dx by itself. So now the calculus is done. We have just finished up the calculus. Now we need to do the algebra. And remember, the hardest part of calculus sometimes isn't the calculus itself, it's the algebra that comes with it. So let's go ahead and solve for dy dx. What should I do first? Let me zoom in a little bit too, just so we can see it a little better. There we go. If my goal is to solve for dy dx, right, Gustavo, I'm going to subtract 2x from both sides. So I subtract 2x from here. And remember the golden rule of algebra, what you do to one side of the equation, you must do to the other side of the equation. I'm going to subtract 2x from both sides, from 0 as well. On this side, we can say bye to those 2x's, to that 2x. So I'm left with 2y dy dx is equal to negative 2x. Now what should I do? Also, thank you, CJ, for the heart me. I don't remember if I thanked you for that earlier or not, but thank you. Thank you, Chris, for sharing the live. So what should I do here if I want to get dy dx by itself? Thank you, Rice Senpai, for sharing the live. Divide by 2y, that's exactly right, Kay. So I'm going to go ahead and I'm going to divide both sides by 2y. So 2y. Because remember, what I do to one side, I have to do to the other. So on this side, I can say bye to my 2y's. And on the right, I can simplify this by saying bye to the 2's because I'm multiplying. So I'm left with dy dx is equal to negative x over y. And that is our answer. Thank you, Bryn, for the follow. Absolutely, this is what we're currently on right now. Awesome. Why did you divide instead of subtract? That's a good question, user. So here. So I assume you're talking about this step right here. Okay, yeah, so the reason why I divided by 2y is because the goal is to get dy dx by itself. It's as if I had this. Let's say I had 3x equals 12. And I wanted to solve for x. So what I can do is I can divide both sides. So here, Whenever I have a number next to a variable, it means I'm multiplying. So in order to undo the multiplication, I would have to divide by 3. But again, what I do to one side, I do to the other side. So here, I'm multiplying 2y and dy dx. So in order to undo this multiplication, I would have to divide by what I'm multiplying dy dx by. Thank you, Bryn, for the follow. Thank you, Wells, for sharing the live, and thank you for sharing the live again, and thank you, All Balin, for the follow. Can't you substitute for y? Where would I substitute for y? What would I substitute for y? Thank you, All Chiefs and Carly and User, for the follows. What unit is this? So this is, I think it's either unit, I think it's unit 3 or 4. I want to say towards the end of unit 3. Hey, Daniel, how's it going? How's it going? Is this pre-calc? Nope, this is calculus. So let's take a look at the steps on how to solve an implicit differentiation problem. And we'll write this out as we do them. So steps to solve implicit differentiation. Oh wow, we're already almost. Do you only teach calc? What about differential equations? Yep, I do differential equations as well. But right now, we are just working on calc 1. Problems. You can do another way to be more explicit. But I want to be implicit. I want it to be implicit differentiation. Yeah, I could. So, so I'm assuming you. I assume that we would want to solve for y. Yes. Yeah, going. Good night, gang. I'm dropping out. No problem, Zyru. Have a good night. Have a good night. Thank you for the love me. I love you so much, Carly. Thank you so much for that. So, let's go ahead and try another problem with implicit differentiation. So, go ahead and get one out. So, let's do. Ooh, that one looks fun. Honestly, seems. Yeah, yes, sir. Keep the problems coming. Aye, aye, Captain. Calculus jump scare honestly seems scary, but it comes down to knowing the algebra and, of course, the laws. Absolutely. I agree 100%. When it's not explicitly defined as a function of x. Right. What's the difference between implicit and explicit? So, implicit differentiation is when I don't have a variable, when I don't have a function of y in terms of x. Rather, I have a relation between two or more variables. Okay, this is taking too long. Okay. Most of calculus 2 and 3 is just substitution, in my opinion. That's fair. A lot of it too has to do with being able to go backwards, especially calc 2. When I first started calc 1, I was to the point of dropping this class since I haven't done math in 2 years. Okay. Hopefully you haven't dropped out yet. That's what I mean. Most people don't know how come from dy dx. Okay, so the reason why we have dy dx is because we have to. So this tells us how y is changing with x. So do I need pre-calc for calc 1? It definitely helps, especially the trig part of pre-calc. When taking the derivative, y is introduced with 2y, the dy dx. I assume you're talking here? Okay, so the reason why I had to add this dy dx is because I can only differentiate with in terms of one variable, which is x. So, in order to do this, we're essentially doing the chain rule. So remember how we did chain rule, where I have something other than x inside, and I had to find the derivative of the outer function, leaving the inside alone, and then multiply by the derivative of the inside. The same idea applies here because I can't differentiate. This usually is a function in terms of x, whereas with y, right, it's the derivative of y. So y's derivative is dy dx in terms of x. Correct. What's my favorite food? I'd have to think about that for a little while. What is the most challenging part of calculus, and where does this fall on the spectrum? A lot of people actually struggle with implicit differentiation, simply because they have to remember to add that. It's no, I don't think it's near. I don't think it's in the levels of related rates or optimization or something like that. But I would say this is like I would say this is like a I would say this is like a 6. dydx can also be thought of in terms of solving for y then taking ddx, but that comes later. Fair enough. Thank you, Malcolm, for the follow, and thank you, Yvonne, for the share. I missed Calc 1. Calc 1's not Calc 1's actually not that bad, I think. Calc 2 I think is Calc 2 I think is the most difficult of Calc 1, 2, and 3. So let's go ahead and try another one. I think Calc 3 is harder to visualize. I agree. It's in 3D and it can for me I have trouble drawing in 3D. Drawing on the 3D plane, or drawing the 3D plane. So I definitely can see that. Differential equations or Calc 3, what's worse? Um Honestly, I struggled more with differential equations than I did Calc 3. Calc 3 is so abstract. Agreed. Even when I'm not trying to see math, I still be seeing it. You see it every day. You are math. Math is something that you will never escape from. Math is everywhere in this world. What is it about calculus that makes it challenging as a class? I think I think there are a couple things. First, I think that it's a basically a combination of algebra and trig, and a lot of people I find struggle with one or the other, and it comes together. You literally learned this 3 days ago. That's awesome. Thank you, Nature Lover, for the follow. Agreed. I think what makes Calc challenging is a lot of people don't brush up on their algebra. Agreed. Can you explain from the beginning? Sure. So instead of doing that, let's do another problem. I love implicit differentiation. It's fun. Thank you, Swarm Truth, for the follow. Thank you, Smokes, for the follow. Thank you, Miso, for the follow. So, let's go ahead and try another one. Let's try the following problem. Let's try... So I have... Thank you, Bill, for the follow. So I have y cubed minus 4y squared is equal to x to the fifth plus 3x to the fourth. Thank you, Reese's Pieces, for the follow. And thank you for the share. I did this last week in my AP Calculus class. That's cool. Do you teach Calculus 2 on these lives? I will be soon. Looks like algebra. It does involve algebra, but it's calculus. So a lot of these so with these implicit differentiation problems, we're going to be differentiating with respect to x. So here we go. So I have give x that respect. Indeed. So now, first step is to take the derivative of both sides. So 1. Take derivative of both sides. So here, I have the derivative of y cubed. So remember, y's derivative is dy dx. So, what would be the derivative of y cubed? Well, here, I'd use power rule. So power rule says take the power, move it on down, subtract 1 from the power, that's 3y to the 3 minus 1, which is 2. And then remember, since y's derivative is dy dx, I have to include that as well. dy dx. Thank you, Cassandra, for the follow. And thank you, Not Roger, for sharing the live. So from here, what will be the derivative of 4y squared? Make that look like more like a 2. There we go. Lim says 8. Diamond says 8y. Miso says negative 8y dy dx. That's right, Miso. So here, 4 times 2 gives me negative 4 times 2 gives me negative 8. Y to the 2 minus 1. 2 minus 1 is 1. So remember, a variable without an exponent is the same as that variable raised to the first power. But then, I need to remember, derivative of y is dy dx. And now I'm done on that side of the equal sign. Thank you, Z, for the follow. So then, what's the derivative of x to the fifth? And I promise you don't have to do dx dx. Almost, Mizakar. Yes, Obadiah. Yes, Miso. It's 5x to the fourth. So I have 5x to the fourth. And then what's the derivative of 3x to the fourth? Alexander says 12x cubed. Obadiah says 12x cubed. Misakar says 12x cubed. Miso says 12x cubed. Lim says 12x cubed. Ben says 12x. Blue Trash Panda says 12x cubed. Rolling says 12x cubed. Diamond says 12x cubed. Bill says 12x cubed. So yeah, that's exactly right. It looks like we have a consensus. Why do you have to write why do you have to keep writing dy dx? That's exactly right, Miso, because we're essentially doing chain rule. And the reason why we're doing chain rule is because y is, so we differentiate with respect to x. So because y has no x's in it, I have to write it as dy dx. You understand it? That's awesome. Way to go. Yes, Samuel, that's exactly right. I'm going to factor out the dy dx next. So here, now, thank you, Bon Grov, for the follow. So my second step is solve for dy dx. So if it was respect to y, it would be correct. Yes. Thank you, Jesse, for the follow. Oh wow, 80. I don't think I've ever had 80 plus people in a live before. So thank you all for being here tonight. I think this is a new record. If not, we're getting really close to it. I've never had triple digits on here before. Thank you, John, for the follow. Brings back memories? Absolutely. Thank you, Alexander. I'm really happy to hear that. So let's solve for dy dx. So here, as Samuel said, let's factor out the dy dx on the left side of the parentheses. Or left side of the parentheses. Good job, Robert. Let's try that again. On the left side of the equal sign. So, we have dy dx. I'm going to factor that out. And what am I left with? Well, remember, when I factor something out, 100 people in the live. Let's go. Thank you all. This is definitely a new record. 100 people are in here learning about calculus. Sounds like this is an awesome night. So now let's factor out the dy dx and let's see what's left. So I have 3y squared dy dx divided by dy dx gives me 3y squared, and negative 8y dy dx divided by dy dx gives me a negative 8y. And on the other side, well, I don't have any dy dx's to factor out, so I can go ahead and just write that out. Thank you, Devin, for the follow. 5x to the fourth plus 12x cubed. Now, remember, our goal is to solve for dy dx, so what should I do next? What should I do next to solve for dy dx? We need help with calculus. Appreciate your work. Thank you, Diamond. Divide. Yeah, well, everyone's saying divide. So, yeah. So I'm going to go ahead and divide by whatever's inside the parentheses. So I'm going to divide by 3y squared minus 8y. And remember, what I do to one side of the equation, I have to do to the other side. Minus 8y. What am I left with? On the left, we say bye to this. So I'm left with dy dx. And on the right, I'm left with 5x to the fourth plus 12x cubed all over 3y squared minus 8y. Thank you, Little Lulu, for the follow, and thank you, A Little Too Creamy, for the follow. So if we wanted to simplify this completely, what I'm going to do is I'm going to go ahead and factor out an x cubed on top. That would leave me with 5x plus 12. On the bottom, factor out a y, be left with 3y minus 8. dy dx. I can't simplify further, so we are done. Thank you, Swarm Truth, for the coconut and the heart signal. The 2 heart signals. Thank you, Panda, for the follow. Thank you, TT Olivia, for the follow. Real math guys always finish to completion. Absolutely. Thank you, Me Like Cows, for the follow. Thank you, Bab, for the follow. Thank you, Victor, for the follow. 135. This is amazing. Is that a galaxy? That's the first galaxy I've ever had. So thank you, Swarm Truth. I've never had a galaxy on here before. This is just amazing. How about integration by part? So tonight we're just doing implicit differentiation, but we do have I do have integration by parts here on my here in on my list. Let me actually show you the list. So my integration by parts is right here. Can I see original equation? Sure. How often do I go live? I go live. I try to go live every day at 11:30 p.m. Eastern. Thank you for the money gun, Bill. How about taking the integral on both sides? So in order to do that, I'd have to do this thing called separation of variables. So I'd have to separate my dy dx so that my my x's are on one side and all my y's on the other. Thank you, Kubachel, for the follow. Thank you, Dan, for the follow. Are we doing derivatives and instantaneous velocity? We're doing instantaneous velocity later, but yes, we are doing derivative. Thank you, Malik, for the follow. But yeah, I'm going to go ahead and take a quick screenshot. I have to remember how to do it on my computer. Thank you, Golden Eye, for the follow. Thank you, Ekidden, for the follow. Thank you, Lim, for the follow. This is a moment. So how do I take a screenshot on my Windows? Okay. So it's this command. There we go. I just took a screenshot. Thank you all for this. Thank you, Princess Peach, for the follow. You deserve it. Thank you, Obadiah. I'm really yes, I am really happy. Thank you, Rachel, for the follow. Can you solve us the wave equation and its implicit solutions? I actually don't. I'm actually not as familiar with the wave function as I probably should be. Thank you, Rachel, for the follow. I'm an engineering student and I want to have a better foundation. Okay. We learned inverse functions for trig and it's much to memorize. Absolutely. Yeah, unfortunately, I have to learn more about the wave function before I can show you its solutions. Are we doing partial differential equations? I've actually never done partial differential equations before. That is something, though, I should probably learn about myself. Can we do contour integration? Can you do contour integration? I've heard of contour integration. If I've done it, it's been a very long time. It's like Algebra 2. My dad teaches differential equations. That's cool, Lena. That's really cool. Thank you, Lisa, for the follow. All right, let's do another one. This time, let's do some trig. Let's throw some trig in there. Why not? So let's do sine of y squared minus cosine of x squared. Actually, I just realized I may have not given myself enough room, so I'm going to go ahead and move down a little bit. That way I can give myself a little more space. So sine of y squared minus cosine of x squared is equal to cosine y squared plus sine of x squared. Can you do undefined integrals, please? Undefined integrals. Are you talking about something like this? No? Hmm. I'm not sure. When are we hitting Oilers? That's when things start to get scary. Oh, Oilers number? Oh, when the integral has infinity. So we're talking about like this. So like negative infinity to infinity. I have a calculus exam and didn't take pre-calculus last year. How should I get to learning calculus? So really the thing about calculus is that it requires two things. First, it requires a strong algebra background, a strong knowledge of algebra, and also a strong knowledge of trigonometry. Pre-calc gives you that knowledge, but if you haven't taken it, if you when you if you haven't taken pre-calc, it's what was I gonna say? Oh, so without can someone pass calculus without taking pre-calc? Absolutely. I just think that you need to have um those two foundations before you take calculus. Use Google Gemini guided learning mode; it will change your life. I'll have to look that up. Do you teach pre-calc? I do. You don't really need pre-calc to be honest. It's debatable. Can I please have your brain? I'm I what about me? What would I do without a brain? So tonight we are doing implicit differentiation. We're gonna get to integrals soon. I'm planning on getting to integrals in October. Yeah. Thank you, Rabbi, for the follow. Thank you for the follow. And thank you for all of the gifts tonight. I found it the other day going back to for electrical engineering at 35, coming back into Calc 3 stuff. Absolutely. There was a time where I hadn't done calculus in like like 7, 8 years, and I just forgot everything. Thank you for the roses, SJ. Math isn't difficult. People just get in their head that it is, and they believe it. Absolutely. So, and that's the thing. Our experience, math isn't horrible. It's not a scary monster, as I say. Um, I think it comes down to I think it comes down to to people's experience. Like I've had teachers where they will literally teach like this. Okay, class, today we're gonna talk about implicit differentiation. Uh, it's 8 a.m. in the morning, and I know you all want to fall asleep, but you can't because you're in the class. Oh, I'm gonna keep talking like this, so that way I can catch you trying to fall asleep. I'm so bored of this that it's not even funny how bored I am. Um, so my boredom, I'm gonna share with you my boredom, so that way you can be bored and worried about this as well. I have to admit, I don't do a bad Bill Belichick impression, especially especially when it comes to like I'll admit it, I'm a New England Patriot fan, and I I would always find it interesting listening to Bill Belichick in his press conferences. But I've had teachers literally talk like they were Bill Belichick, talking about how and it was like it was 8 a.m. Can you imagine being in school at 8 a.m. doing math with a teacher who sounds like that? It's crazy. Or they assume too much and you can't follow how they get to point it. Exactly. And like I said, when I teach, I like to teach one of two ways. Either A, how I was taught, or B, how I wish I were taught. Thank you, Oi, for the follow. That's if you can understand them. Yeah, definitely. You need pre-calc, especially if your calc professors ask you to do problems that need trig identities. Absolutely. And that's the thing. I tell my students all the time. I may ask you if you have any questions a lot. It's not me trying to be annoying. It's me making sure you understand the concept, so that way, if you have if and when I tell them that, it's like, yes, I'm going to be annoying and I'm going to ask you if you have any questions practically after every problem, but it's because I want to make sure that you understand what I'm doing. Because if I do a layer problem and you don't understand this, then yeah, and that's why I ask you all if you have any questions basically after every problem. Like that, is it annoying? Maybe, but I would rather be annoying and try to try to help you with these and make sure you understand these rather than just assume, oh, you know this stuff, don't worry about it. Do you also teach pre-calc? I do. You need help? Okay. I tutor. Let me pull up my list. And for those of you who have been here a while, you know that the list is pretty expansive of everything I tutor. Do I have a channel there? Yes, I do. So here is a list of every subject I tutor. So the channel I have over there is the exact same name as this channel. It's Main Street Math Tutoring. So many note cards. Thank you, Jack, for the follow, and thank you, Karen, for the follow. Oh, here it is. Where does trig line up? Usually trig is here. Do you have any recommendations for exponent rules and logarithm rules? I have class on this tomorrow. Okay, so really with exponent rules, there are 7 of them. There are. Thank you, David, for the follow. So there are. So really, it's think about it. Think about what it means to have an exponent, right? So remember the exponents, and I do want to get to that problem. So we'll get there in just a moment. And thank you, Debbie and Rod, for the follow. Sorry, Rod. For a second, it looks like an E. So remember what it means to be an exponent. Like if I have x squared, it means take x and multiply it by itself twice. So if you understand what an exponent is, then its laws derive themselves naturally. In fact, and then for logarithms, just remember the golden rule of log. So log base a of b equals c is just another way of saying a to the c equals b. So yeah. So now let's find dy dx if this is true. So I'm going to go ahead and first, remember my first step. What's my first step to solving an implicit differentiation problem? My first step is to take the derivative of both sides. I think that says Thank you, Milk, for the follow. So, here's what I'm going to do. I'm going to take the derivative of both sides. So here, I have chain rules. So instead of take the derivative of both sides in respect to x, correct. So what I'm going to do is so here I'm doing chain rule essentially twice. So instead of finding the sine of y squared, let's quickly find the derivative of sine of bottle cap. What is the sine of bottle cap? What is the derivative of sine of bottle cap? Yeah, sine of bottle cap, I know, right? Yeah, it's cosine. So we have cosine of bottle cap. What's underneath the bottle cap? It's y squared. So then I need to find the derivative of y squared. What's the derivative of y squared? Cosine of bottle cap times the derivative of bottle cap. That's right, Mary. That's exactly right. Mitt says 2y. Alexander says 2y. Yes, Samuel. It's 2y. I'm going to write the 2y here. And then I need to multiply by dy dx. Why? Because remember, the derivative of y is dy dx. So it's important to remember that anytime I'm taking the derivative of y with respect to x, I need to include this. That is two chain rules. That is indeed. And I have a feeling I'm going to run out of space. We'll make it work. And now, what is the derivative of cosine of x squared? Well, instead of finding the derivative of negative cosine squared, let's find the derivative of negative cosine of bottle cap. Manifest enough space. Mitt says sine. Alexander says sine. Mary says sine of bottle cap times d bottle cap dx. Yeah. So it's going to be, remember that this is negative cosine, and the derivative of cosine is negative sine. So the derivative of negative cosine is positive sine of what's underneath the bottle cap is x squared. And then what's the derivative of x squared? That's right, Mary. It's 2x. That's right, Mitz. That's right, Diving. That's right, Obadiah. That's right, Alex. That's right, Angel. It's 2x. So now I've found the derivative of this side of the equal sign. I'm going to put the equal sign here, but I'm going to continue writing down here. Now, let's find the derivative of cosine of y squared. Thank you, Basement Crusader, for the follow. Yes, where's the bottle cap? The bottle cap is right there. You can't do chain rule without your bottle cap? Fair enough. Thank you, SJ, for the follow. Angel says negative sine. Alex says negative sine. Sal says negative 2 sine x. Almost, Sal. Mary, that's right, Mary. It's negative sine of whatever's underneath my bottle cap times the derivative of the bottle cap. So what's underneath the bottle cap? It's negative. It's y squared. Did I say negative? I meant to say just y squared. And then the derivative of y squared is going to be what? It's going to be, right, Obadiah, it's going to be negative, it's going to be 2y dy dx. Let me make that look more like a, and I just realized now I meant to put the 2y there but I didn't give myself enough room on the negative sign. And then, what's the derivative of sine of bottle cap? The derivative to this is pretty elegant for a problem you spawned in randomly. I'm actually I'm actually testing out a book and seeing sometimes I can't I don't sometimes I do spawn in problems randomly, but sometimes I'll use a book as well to give me some problems. So yeah, the derivative of sine is cosine. So this is going to be plus cosine, when you give myself enough space, of what's underneath my ball cap is x squared. And then times the derivative of x squared, which, right, Obadiah, it's going to be 2x. So now, my second step, the calculus is done. Now we just solve for dy dx. So what should I do first? So I have a dy dx here, and a dy dx here. I could factor out, but I have to do that first, right, Samuel? I have to move my dy dx's to one side and move everything else to the other side, right? So we can do this one of two ways. I can either subtract 2y cosine y squared of dy dx to both sides, and then add 2 or subtract 2x cosine of x squared. But what I'm going to do instead is I'm going to add sine y squared times 2y dy dx to both sides. And I'm going to subtract 2x cosine of... Oh, wait, no, I don't want to do that. I want to subtract 2x sine x squared. I don't want to get rid of everything on one side. So we can say bye to those. What am I left with? I'm left with 2y cosine y squared dy dx plus sine of y squared, or I should put the 2y. I need to remind myself to put the 2y on that side. Dy dx is equal to 2x cosine of x squared minus 2x sine of x squared. Okay, Mary, have a good night. Thank you, Alexander, for sharing the live, and thank you, Dav Meow, for the follow. So now, oh, yes, fair enough. Yes, bye. I'm definitely a 90s child. So now, I'm going to go ahead and factor out my dy dx. So dy dx times the following. So I have this divided by dy dx is 2y cosine of y squared plus, I'm going to move the 2y over here this time, 2y sine of y squared. And that's going to equal, I could factor out 2x right now, so I'm going to go ahead and do that. So 2x times cosine x squared minus sine x squared. Pythagorean identity. Are you talking about the sine squared plus cosine squared equals 1? So that would work if my squared were above the cosine, or if I were squaring cosine of x all squared. Right. Almost, though. So now, in order to get dy dx by itself, finally, what do I have to do? What's my last step? Scope says divide. Yeah, that's right. So I'm going to divide everything on this side, everything by everything that's in the parentheses, not including dy dx. Right. So I'm going to divide by 2y cosine of y squared plus 2y sine of x squared. And what am I left with? Well, I'm going to use this space down here so that way I can. Thank you, Aimer, for the follow. So dy dx, I'm going to write it down here so that way I have some, so that way I can try and fit this. Dx equals 2x times cosine x squared minus sine of x squared. There we go. All over. And what I'm going to do on the bottom is I'm going to factor out a 2y as well. Cosine y squared plus sine of y squared. Final step. Bye 2's. And that is our answer. Implicit differentiation is in both A, B, and B, C. That's right. Thank you. Thank you, Dasapi, for the follow. I see we're just started on derivatives. We've been doing derivatives for a little bit. Yeah, no problem, Obadiah. Thank you for joining us. Have a good night. So our final answer is dy dx is equal to x times cosine x squared minus sine x squared all over y times cosine y squared plus sine of y squared. Good night. I got to do this, but with inverse functions at 7:30 p.m. tomorrow. Okay. Have a good night, Samuel. Thank you for joining us. Actually, I'm going to circle my answer so that way we can show that we are done. Why won't it complete the circle there? No matter. Time for a different pen. OMG, I literally just learned this today. That's awesome. That's really cool. I forgot which calculus this is. This is Calc 1. Can you show the work from start to finish? Sure. Here's our work. Can you explain partials and gradients? So tonight, I just want to focus on implicit differentiation, but that is going to be on my list. It has been a while. It's been a while since I've learned French, so here goes nothing. Thank you, Guinea Historie, for the follow. Merci beaucoup. And thank you, Kim, for sharing the live. You just learned this in BC today. That's cool. That's really cool. So let's do a couple more of these, and then we will call it a night. You should teach proofs and logic too. It's useful for people who want to take analysis calculus. Good. That's not a. That's actually not a bad idea, John. Do you think AB or BC junior year is better? That depends. Did you have you taken calculus before, or are you taking, or what, or did you just get out of pre-calc, or are you currently in pre-calc? Right. So AP calculus AB is going to give you calc 1. BC gives you calc 1 and calc 2. Exactly. Yes. I took pre-calc last year and have to decide between AB or BC, and they're both full year. So the difference between AB and BC is that BC moves at just a little bit of a faster pace, and there are a couple more units to BC than AB. That said, on a scale of 1 to 10, how did you how did you do in pre-calc? 96. Take BC. Give BC a try. I think you can do it. Holy tangents. Yeah, I know, right? My counselor swears I'm doomed in BC because I took pre-calc and not honors pre-calc. Well, at the end of the day, it really is up to you. I think you could do. I think if you did that well in pre-calc, that you can handle BC. But that's just my opinion. At the end of the day, that all that matters is what you think, because you. I don't know. Absolutely, BC is not. BC is not. BC is not scary. It's just going to be involved. So if you, so it really like that. It really Do you do math only, or do you do engineering stuff like heat and man? I have no clue what I'm talking about when it comes to engineering. I honestly I've never been an engineer, so I don't know about a lot of that stuff. But I like to stick with math. Where was I a pure math major? So I only have a bachelor's degree. So we didn't get to choose between pure and applied. It was just math. Ooh, this is my third time turning the page horizontally and not vertically. Okay. Okay, that's really cool. I'm glad I don't have to lift the page up and down anymore. If I take AB now, isn't BC just next year just repeat of same stuff for the first half of year? Yeah, if you're gonna take BC your senior year, just do it this year. That's like that. That's my personal opinion. Which classes did you find most interesting in undergrad? So honestly, the class that I had the most fun with was abstract algebra. Um, but it was because my teacher taught it in a way where it was proof based. So he would give us um, just enough information for us to do the proofs, and then he would just let us go do the proofs the rest of class. Galois theory is so interesting too. I've heard that. I've heard that. I have to check it out. Do I teach it? Do I teach calculus? I actually left the classroom about 7 or 8 years ago, but I tutor nowadays. So yes, I do tutor this. Yeah, you. I believe in you, Sam A. I believe in you. What did I teach was when I was in the classroom? Um, so the last year of my teaching, I was teaching at a middle school. So I did the basic middle school curriculum. Hey, Dimples, how's it going? But when I was teaching high school, I taught algebra. I taught a little bit of calculus. I taught geometry. I'm good. I'm doing great, Dimples. It's a great night for to be on a live because I took pre-calc instead of college honors pre-calc. Why? Why is it a prerequisite? Yeah, just do that. Yeah, absolutely you can. Your counselor can't tell you which exam to take. That's completely up to you. So, as I understand it, yes. Because if you fail the exam and pass the class, you don't get the college credit. Watching you is what prepares me for the next day lecture. That's awesome, Alexander. I guess I'm a little ahead of what you're learning about. But given that I'm on practically every day, I should be ahead. And also, I'm going to win my fantasy football game this week. Yes. All right. So let's go ahead and do a couple more of these, and let's call it and after that, we'll call it a night. So I have find. Oh wow, yes, I do like that I don't have to try and because on the other sketch pad I had when I flipped it up, what would happen is I would poke holes unintentionally into the paper, and I like that I don't have to do it. I'm not doing it with this. So find dy dx. Thank you, Heat88, for the follow. So find dy dx if 3x squared plus 5xy squared minus 4y cubed is equal to 8. So here we go. So first, I'm going to go ahead and take the derivative of both sides. There are also tons of free calculus resources online. Yeah, agreed. Yeah, I'll say I have the credit, my boy, and then Calc 3 is multi or and linear are a bit different. Yep, that's right. Calc 3 is multivariable. Linear algebra is a completely different class entirely. So linear algebra deals with how to solve systems of equations with a ton of variables. And I mean literally a ton. So yeah, let's go ahead and solve this. So let's go ahead and find the derivative of both sides. So on this side, let's start with 3x squared. So we taking multivan? Right now we're working on calculus 1. But yes. So what is the derivative of 3x squared? Alexander says 6x, me says 6x, Cisco says 6x, Ty says 3, Karma says 6x, Sean says 6x. So it looks like we have a consensus, yeah. So remember power rule. What does power rule say? Power rule says take the exponent, move it out front, and multiply by whatever coefficients out front, and then subtract 1 from the exponent. So 3 times 2 gives me 6. X to the 2 minus 1. 2 minus 1 is 1. And so remember, a variable with an exponent is the same as x to the first. So now, what about this 5xy squared? So, what if I told you we had to do product rule to solve that derivative? Thank you, me, for the follow. So essentially, I'm multiplying two different functions together, so I need to do product rule. What does product rule say? Well, product rule says, let me pull out my list of rules. Really need to organize my note cards. There you are. So, what does product rule say? Product rule says that if I have a function times another function, its derivative is equal to the derivative of the first function times the second function. And then we switch the partners around by taking the derivative of the second function times the first function, and we add them together. So my first function, which I'm going to label in or where did my there's my pencil. So my first function is this 5x. So I'm going to let g equal 5x and h equal y squared. What is the derivative of 5x? Miguel says 5, John says 5, me says 5, Dan says 5. Yeah. So it looks like we've come to a consensus, and that consensus is 5, which is right. What about the derivative of y squared? Me says 2y, John says 2y dy dx, Dan says 2y, Sergio says 2y. Yeah, so most of you were almost there. John. So it's 2y right out. So it's 2y times dy dx. Remember, it's when we differentiate with respect to x, if I have a variable that's not x, I need to include that dy dx. Another way you might see it is like I have here, h prime. If you see dy dx or y prime, just know they are the same thing. So now let's do product rule. So I'm going to link those two together, and I'm going to link those two together. So the derivative of this is going to be the derivative of 5 is going to be g prime times 8. So this is going to be plus 5y squared plus the derivative of times the derivative of first plus the derivative of the second times the first. So I have 5x times 2y. So that's going to be 10xy dy dx. Right? Because 5 times 2 gives me 10. Have a good night, John. Thank you for joining us this evening. And then, what's the derivative of 4y cubed? What is the derivative of y cubed? Of 4y cubed? Alexander says negative 12y squared. Me says negative 12y squared. Almost. You're missing something. Right. So it's negative 12y squared. You were right there. But remember, I have to multiply by dy dx. And then, what's the derivative of 8? That's okay. Right, it's going to be 0. Right? Why? Because the derivative, remember that 8 is a constant, and whenever I have a constant, its derivative is 0. So I'm going to set that equal to 0. So now my next step is to solve for dy dx. So, thank you, Anthony, for the follow. So, now what I'm going to do is I'm going to go ahead and solve for dy dx. So first, I want to get rid of everything that does not have a dy dx on with it. Thank you, Sergio, for the follow. So here, first, what should I do? If I want to get dy dx by itself, right? So I can subtract 6x from both sides, right? Can I do anything else? So why is 3x squared not 9x? That's a good question. So the reason why this isn't 9x is because x is the only thing being squared. If I had 3x in parentheses all squared, then or if the 3 were just being squared, then it would be 9x. But the 3 is not being squared. Right, Dan. So I'm going to subtract 5y squared from both sides as well. So here, no problem, Ty. No problem at all. So I have 10xy rather, dy dx minus 12y squared dy dx. And that's going to equal negative 6x minus 5y squared. Now I'm going to factorize. That's right. So I'm going to factor out the dy dx. Let's factor that out. And I'm left with what inside the parentheses? What goes inside the parentheses? Alex says 10xy minus 12x squared. Dan says 10xy minus 12y squared. Yeah, So it looks like we've come to a consensus. It's going to be 10xy minus 12y squared. And then my final step, I'm going to go ahead and divide that everything that's being multiplied by dy dx, which is what's inside the parentheses. And I'm left with dy dx is equal to negative, I'm going to factor out the negative sign. So I have negative 6x plus 5y squared over, let's go ahead and factor out a 2, or I could factor out a 2y, and I'm left with 5x minus 6y. I don't think I can factor further, so I'm going to call it done here. Thank you, William, and thank you, Clope, for sharing the live. And that's it. I know, right? So, let's do one more, and then we'll call it a night. We'll do the final problem. There are 60 of us in here. I think 25k likes for the final problem is realistic. Thank you, Cisco, for the follow. Let's do a quick mad tap. Let's see if we can't get to 25k likes. Yeah, I just factor out a negative. I need your live schedule. No problem. It's really easy to remember. It's 11:30 p.m. Eastern every single day. I'm working on doing a second live, but I'm waiting until my tutoring students have their schedules settled before I do that. Thank you, Uncrustable, for the follow. Ooh, those look fun. I'm in Calc 2 right now and forgot how to do this. That's fine. Well, that's why we're here. That's why you were here, that you clicked on this tonight. At least I'm going to choose to believe that. So yeah. Let's get to 20. Let's get to 20k likes. And then we'll do a final problem and call it a night. Thank you, none of this nonsense, for sharing the live. Excuse me. While you do that, I'm just gonna go get some water quickly. I will be right back in just a moment. Here we go, I'm back. I'll let you choose what the final problem is. Do we do problem A or problem B? Which one would you like to do? Problem A or problem B? All right, let's do problem A. So, let's find the derivative of 3x squared minus 4y squared plus y equals 9 at the point 2 comma 1. So, what should we do first? Well, let's take the derivative of this relation first. So what's the derivative of 3x squared? Right, Ty, it's going to be 6x. Right, 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 Mafia, it's going to be 6x. And then, what's the derivative of 4y squared? Or negative 4y squared? All right. Ethan says 200. Mafia says negative 8y. Wiz says 8y. Ty says negative 8y squared. All right. So remember, I'm going to do power rule. Power rule says take the exponent, move it out front, and multiply by any coefficient that's there. Thank you, hard worker, for the follow. So it's going to be negative 8y. But remember, there's a y there, so I need to include a dy dx. And then, what's the derivative of y? Wiz says 1. Almost, Wiz. You're missing something because that's y. So what else do you need? Right, Alex. It's going to be, we need to add a dy dx or y prime, right? So if you want to write y prime instead of dy dx, that's perfectly fine. And then the derivative of 9 is going to be 0. So now we can do this one of two ways. Either A, we can solve for dy dx and then plug in our point, or we can plug in our point and then solve for dy dx. Which one would you rather do? Both are going to get us the answer. Plug in. Okay, let's do that. Solve first and evaluate. Okay. So what I'll do is let's do both. So I'm going to write. So on the left, we'll go ahead and solve and then evaluate. And on the right, we'll evaluate and then solve, or plug in and then solve. Y dx equals 0. On the left, let's go ahead and solve for dy dx. So first, I'm going to subtract 6x from both sides, which gives me negative 8y dy dx plus dy dx equals negative 6x. From here, what should I do next? What type of math is this? This is calculus. Factor out the dy dx. Right. So I'm going to factor out my dy dx out of here. And inside the parentheses, I'm going to be left with what? I'm going to be left with negative 8y plus 1 equals negative 6x. Right, me. That's right. And then that's right, Ty. I'm going to divide by negative 8y plus 1. So dy dx is equal to negative 6x all over negative 8y plus 1. So now from here, I'm going to plug in 2 for x and 1 for y. So I get dy dx equals negative 6 times 2 over negative 8 times 1 plus 1. What is negative 6 times? What would my answer be here? Thank you, Goofy, for the follow. Lucas says 12 over 7. Stair says 4/3. Almost. Watch your signs, Lucas. Oh, wait, no. Yeah, never mind. I'm wrong. Negative 6 times 2 is negative 12. Negative 8 times 1 is negative 8, plus 1 is negative 7. We can say bye, bye, bye to the negatives. So my answer is 12 over 7. That's it. Thank you, Jackson, for sharing the live. So now, let's go over here, plug in my points now, and then solve. So I have 6 times 2 minus 8 times 1 times dy dx plus dy dx equals 0. 6 times 2 gives me 12. Negative 8 times 1 gives me negative 8. dy dx plus a dy dx equals 0. Because I have this, because I have a dy dx here and a dy dx here, and I'm adding, I'm going to combine my like terms. This is going to be 12 minus 8 dy dx plus 1 dy dx is going to give you minus 7 dy dx. From here, we have to set that equals 0. From here, I can do one of two things. I could either add 7 dy dx to both sides, or I can subtract 12 from both sides. What I'm going to do, since I really don't want to deal with that negative, is I'm going to add 7 dy dx to both sides. Dy dx. So I get 12 is equal to 7 times dy dx. And finally, divide by 7. That goes away, and I'm left with dy dx is equal to 12 over 7. Is this differential equations? Nope, this is calculus. So as you can see, no matter what we did, we got our answer. Thank you, Vanille Show, for the follow. I always like to solve for y prime first in case there's multiple points being asked, and I like, fair enough. If this helps you, then go for it. I just wanted to show that no matter what we did, we got the same answer. But yeah. So with that, we'll go ahead and call it a night for the math. But like I said earlier this week, I want to try and be on 2 hours a night. So as you can see, we have about 15 minutes left. So at this point, let's go ahead and just talk for 15 minutes. How's everyone's weekend? Just started teaching high school math has been intimidating. Okay, Lucas, what are you teaching? Geometry and algebra 1. That's really cool. How many how what's your average class size? Hated geometry in high school. I did too. I did too. I think algebraically, so geometry is not easiest not the easiest class I've taken. 35, so I have 150 kids. Okay. Is this ODEs? Nope. This is calculus 1. This is implicit differentiation. Limit is too hard. Okay. What are you working on with limits right now? But yeah, I find that a lot of students either struggle with algebra or geometry. I struggled with geometry more than I did algebra, personally. But I know a lot of kids that struggle with algebra and are really good with geometry. It really all depends. Me too, hoping to find ways to keep kids engaged and focused. Yeah, and that's the difficulty with math, right? Especially when you have students that have had bad experiences with math, so they automatically assume that they hate it. And to be honest, the way some of my teachers taught, I don't blame them. I don't blame my students for not liking math because I've literally had teachers who, and it wasn't just math, but I've had teachers that would talk like this. Okay, class. So today we're gonna talk about implicit differentiation, and I know it's 8 a.m. in the morning, but I'm bored. So and I don't like this, but I have to teach it anyway. So let's get it over with. And I don't know about you, but I'm bored. Did I mention I'm bored? It's 8 a.m. My goal in this class is not to have you learn, but to catch you falling asleep. I don't want to see you falling asleep, even though I'm talking like I could put you to sleep in about 5 seconds with my voice, and it's like I've had teachers literally teach that way, and it's like it's hard to work on. It's hard to learn when when um when you're bored. I'll call it what it is. Yeah, 100%. It's rare to find teachers who genuinely enjoy mathematics. Hoping, yeah, that's awesome, Lucas. Is this your first year teaching, or have you taught, or have um, or have you taught other grades before high school math? Very first year, I remember that. Best of luck to you, Lucas. My advice, make sure that you are well prepared, and make sure that you set the ground rules early in your class. Hey, just started Calc 2. Any advice? Okay. Yeah. How did you do in Calc 1? Thank you, Mile High Sam, for the follow. Yeah, this is implicit differentiation. That's right. I'm trying. Thank you for the advice. I'm gonna go get some rest for tomorrow's school day ahead. Fair enough. Thanks for. You're welcome, Lucas. Like I said, I personally found that I didn't do well in the classroom, but that's okay. It's not for everyone. And thank you for the follow, Lucas. So yeah, you have Are you have quiz tomorrow? Good luck, Solera. On a scale of 1 to 10, how are you feeling about your quiz? How are you feeling about your quiz tomorrow, Solera? I don't know if you're still typing or not. I apologize. But yeah, so um, to answer your question, Devin, um, I would just calculus 2. I think is the hardest of the three of calc 1, 2, and 3, because there are going to be problems that are going to look easy, but they're not. So my biggest advice for you is to make sure you have your derivatives down. Um, Also, Calc 2 is going to involve a lot of substitution and a lot of different rules for those substitutions. So just keeping everything organized is going to help as well. But yeah, so what do we want to talk about? What do we want to talk about for the next 8 minutes? So tomorrow, what am I like a 2 out of 10? Okay, I have little confidence in first order linear. Okay, did you just start the class, or have you been doing it for a little while? If you're doing first order linear differential equations, you're probably just started. If is my guess. Okay, so hmm, I'm gonna tell you this: do your best and realize that just even if you don't do well on this quiz, just know that it's not gonna make or break anything. Can you explain when a function is neither continuous nor differentiable, and when it's continuous but not differentiable? Sure. So if a function is not continuous, it's automatically not differentiable at that point. Um, but so when you have a discontinuity, the function doesn't have a derivative. Why? Because or the function is not continuous. Why? It's not continuous. Or well, duh. It's not if it's not continuous, it doesn't have continuity. But why is it not differentiable? Well, because it's not differentiable because the limit doesn't exist at that point. Like I will let me see if I can find my graph paper here for a second. The continuous but not differentiable is easier. Why? Because when you if you have a function that's continuous but not differentiable, you're looking for a cusp, or what I call the sword. Why can't I find my graph paper? I'll use this paper. Thank you, Stem Shell, for the follow. I'm gonna try and draw a graph, but I have to tell you in advance, I'm not a very good drawer, so I apologize in advance for what will be an awful drawing. So let's say I have something that looks like this. Thank you, James, for the follow. Thank you, Mike, for the follow. So if a function is not continuous, like if I have something like this going on, it's not continuous here. Why? Because the limit. So remember the rules of continuity. There are 3 rules of continuity that have to be met, or 3 conditions rather that have to be met. First, is the function defined at that point? And the answer would be yes, it is. It's defined because there's a y value for that x value. The second, does the limit from the left equal the limit from the right? The answer is yes. Why? Because as I approach this x value from the left and the right, y is approaching the same point. The third condition is that the limit has to equal a value of f at x, which it doesn't. So since it doesn't meet that third condition, it's not continuous. And if it's not continuous, then it automatically isn't. It's not differentiable. But a function can be continuous and not differentiable. So let's say over here, I have this going on. So I have something like that. Well, there's a rule that says that if I go from positive to negative slope, at some point the slope has to be 0. So here at what I call the sword, or the wave, or a cusp, here the derivative is undefined. Why? Because there's no point. It goes, so what, from the left of that point, the slope is positive. To the right of that point, it's negative, but there's no smoothing out to where the slope is 0 here. So that function would be not differentiable at that point. And like I said, this is a really good idea. You can see it. Anything that looks like a sword or a wave or a cusp, the top of it is not going to be differentiable, but it is continuous. How do you determine your lessons? Is there a schedule? Usually, so I go live every night at 11:30 p.m., or at least I try to. Sometimes I'm not very good about it, but I have to be better about it. As far as determining my lessons, I use a few different sources to determine what I'm going to teach next. That, and sometimes I'll go a little out of order, so that because I think something would be better if it were placed there. Thank you, Isaiah, for the follow. Where do I post my lives? That is a good question. I was actually just about to mention that in a moment, but I'll mention it now. So all of my lives, which I still have to download, and I have a lot of them to download because I haven't been very good at doing this or reminding myself to do this. But all of my lives end up, or will end up at one point or another, I put those note cards. I have so many note cards, it's not even funny. I need to clean this desk tomorrow. Oh, here it is. So all of my lives go here. This is the most useless math on the planet. I disagree. Calculus actually has several uses in multiple industries, but yeah. All right. So with that, while I'm here, let's go ahead. You're welcome, Kim. You're perfect. You're most certainly welcome. So before I go, I'm going to go ahead and just share with you a few things. So first are a couple other math TikToks that I recommend you follow. So first is ACG Math Tutoring. She's really awesome. So if you're working on your AccuPlacer, your ASVAB, your GED, your TEAS test, or if you just need a review of Algebra 1 or 2 or Geometry, I recommend you follow ACG Math Tutoring. She was the one who actually convinced me to join TikTok, to join TikTok in the first place. So If it weren't for her, I wouldn't be here on this platform. So definitely give her a follow. Also, if you're interested in learning about the abacus, I recommend Learning with Lynette. I think she's live right now, so as soon as this is done, I will be jumping into her live. And if you do decide to join me in that live, tell her I sent you. Also, as I said before, all my lives are going to end up on this channel. So if you go onto this app and you type in this is my channel over here. And if you do these 5 things, that would be awesome. I can't say this name, otherwise I'm going to get dinged by TikTok, and I don't really want to do that. And then I offer online tutoring. In fact, here's a list of every subject I tutor. So I offer group tutoring, and I also offer one-on-one tutoring. So if you're doing group tutoring, I offer group tutoring for groups of 3 to 10 students who are all taking the same class, but not or at the same time. But it doesn't necessarily mean that you have to take it with the same teacher or even at the same school. So for instance, if you and 3 of your friends are all taking geometry and you're not in the same class or even in the same school, but you are all taking geometry right now, then you can then we can do group tutoring. Also, I offer one-on-one tutoring as well. So if you're interested in either group tutoring or one-on-one tutoring, feel free to give me a DM and we can set up a free consultation. And finally, I have some stuff that I am working on currently and that I have no new updates on right now, other than we're still in the early stages of the design. So I'm making calculus flashcards, and I'm also making a calculus rule set, but I don't want to just make it like every other generic list of derivative and integral rules you find on the internet. Rather, I want to make it into something where it's like, hey, here's what to look for. If you see this, do this. And I'm also working on my first notebook right now. So like that, I'm still in the early stages of all of these, but as soon as these are done, I will have them in my TikTok shop. So cool. With that, have a great night, everyone. Thank you all for joining me this evening. I'm really happy that you all were here. I'm glad that we had over 100 people on this live at one point, which is really awesome. And so with that, have a great rest of your evening, everyone. I will see you again tomorrow, or for me today, because it's 1:45 in the morning here on the East Coast. But I will see you all at 11:30 p.m. Eastern for some 11:30 p.m. Eastern for some more calculus. Have a great rest of your evening, everyone. Bye now.